Hello, today we're continuing with our GCSE physics revision series looking at energy sources. Two key types of sources are known as non-renewable and renewable. The principle being that non-renewable, once you've used them up, they've all gone, but renewable in a sense means that they are constantly being refreshed. So let's have a look first of all at some of the non-renewable types of fuel that we can use, or energy sources. There's coal, which we mine. Coal, of course, is produced, but it takes millions of years, and we're using it up at a faster rate than you can ever produce it. Oil, similarly, there is a finite amount of oil, and once it's gone, it's gone. Similarly, natural gas that we use, that we get out of the North Sea in the UK. Nuclear fuel is a limited supply. There is quite a lot of it, but nonetheless it is a limited supply. And the point about all of these non-renewable sources is that at some stage they're going to run out. But they also, in varying ways, can damage the environment. But at present at least, they are the major source of most of our energy supply. Contrast this with the renewable energy sources such as the wind. That is a kind of renewable resource. You can make winds turn turbines. The waves and the tides are pretty reliable and they constantly come and go. Hydroelectric, which is essentially using water power. Solar power, the power of the sun, will of course we know one day run out, but that's 5 billion years time, so we don't need to worry too much about that just yet. Geothermal, using the heat that is inside the earth itself. And food. We can regrow crops, we can produce biofuels. So the key points about these types of energy is that the energy source is constantly being renewed and replenished. It tends to do less damage to the environment, but quite often those sources are unreliable. If the sun doesn't shine, you don't get much solar energy, and therefore they are less used at present for the production of our major energy needs. The general principle of converting fuels into energy is that you take the fuel, you have some kind of boiler, in other words you often boil or burn the fuel to produce heat. That heat will produce, for example, steam. That steam will drive the turbines, which are essentially things that cause wheels to rotate. And where you've got rotating wheels, you can have an electricity generator, as we've seen with the videos we did on electricity generation, and that generated electricity is then sent up to the national grid, which distributes it around the country. Not all fuels need to go through that process. For example, wind power can come straight into a turbine. The wind is capable of turning a turbine without having to be needing heat or boilers or anything like that. So you go straight to the turbine, and that then becomes its own little generator and can be added to the national grid. So let's investigate some of these forms of energy. Let's take, for example, the wind energy. Each windmill is essentially its own turbine. Within each windmill you've got a turbine and a generator which produces electricity, but you need lots of windmills. And that can often, in some people's minds, spoil the views. There's no pollution in the sense that it doesn't put out carbon dioxide, but there is often what's called visible pollution, that a whole load of windmills in what was otherwise unspoilt countryside spoils that view. You need quite a lot of windmills. 1,500 windmills will equate to one coal-fired power station. You are wind dependent. If the wind is not blowing, the windmills will not turn, you won't get any electricity. There's quite a high startup cost in getting the windmills up in the first place, but having done that, there's virtually no running cost because the windmills just turn. Solar cells can often be seen on houses, on their roofs, but of course they're critically dependent on sunlight. If the sun doesn't shine, you don't get any solar energy. There's no pollution as such, but there is a reliability, and that is a reliability issue which depends on location. Obviously, if you put these things in countries where there is huge amounts of sunshine, then you can be more dependent upon them. If you're in a country or in a part of a country where sunshine is unreliable, then you can't rely too much on it. And there is quite a high start-up cost. People who have these installed on their roofs of their houses generally have to pay quite a lot to do so. But there's no running costs once they're there. They simply convert the solar energy into electrical energy. But it tends to be a fairly small-scale supply, and there's a question about whether it's even worth connecting these to the grid. As often as not, they're simply used to provide the power for a particular household. Hydroelectric power is generally created through falling water. So what you have to do is to flood a valley and build a dam so that you've got a large accumulation of water, and then you allow the water to flow through the turbine, and as it does so it turns the turbine, which in turn of course turns the generator and creates the electricity. There's no pollution as such, but there may be an environmental impact because you have to flood a valley to do it. So what was once a valley with maybe wildlife is now a lake. You can control the flow of the water that flows through the dam by opening and closing shutters, so you can respond to increased or decreased demand. There's a very high startup because you've got to build the dam and you've got to flood the valley. But then there's a fairly low running cost because essentially you're just letting the water run out through the dam, through the shutters in the dam, turning the turbine as it goes. There's a big question about storage of electricity. How do you store electricity if you make too much? Now, we've seen in our own videos that you can store electricity essentially in a capacitor. That will store charge and you can use it later, but that's a small scale thing. It's much more difficult to store huge amounts of electricity that might later go to the national grid. So the secret is to convert the electricity back into something else that you can later convert into electricity again. So if you have a large reservoir full of water and you allow that water to flow to a turbine, and as it goes through the turbine it turns the wheels, which turns the generator, which produces electricity, and then the water flows down into a lower reservoir. On the occasions where the national grid does not need that electricity, what you can do is to use the electricity you've created to pump this water back up into the upper reservoir. And when you do that, of course, what you have done is you've converted electrical energy into potential energy, because this water is now higher than the turbine and it can once again flow through the turbine to create the electricity. So this is a mechanism of essentially storing electricity by converting it into potential energy. And that's called pumped storage, because you've stored the electricity as gravitational potential energy, and that means the water can once more fall through the turbine, creating electrical energy. You can use wave power. This is where the waves of the sea come along. They are simply going up and down, and as they go up and down they can effectively cause a turbine to turn, and that can generate electricity. There's no pollution associated with that. You're simply using the naturally occurring waves of the tides. But it's unreliable. If you've got a calm sea, then you won't get the sufficient ups and downs of the waves to turn the turbine. And there will of course always be an initial cost in setting up the procedure, but then a pretty low running cost because it's simply dependent on the waves. You can use a tide in a different way using what's called a tidal barrage. Here what you do is you have some kind of dam but with tunnels in it. When the tide comes in, the water flows into the reservoir which is behind this dam, and then when the tide comes out the water flows back down through the gates, as it were, or the tunnels. And so when the tide is coming in, the water goes into the reservoir. when the tide is coming out, the water flows out of the reservoir, and each way it can turn the turbines and create electricity. So when the tide goes in, you fill the reservoir, but the water goes past the turbines. When the tide comes out, the water flows out of the reservoir, but both ways the turbine is being turned and electricity is being generated. You get tides twice a day, so they are very reliable, but they are height variable. Sometimes you may get tides which barely change from low tide, so you won't get much flow of water, so you won't get much electricity. And of course 4 times a day, at the point of high tide and at the point of low tide, and you get that twice a day each, so 4 times a day, there is no water flow at all, because the levels on both sides are equal, so there won't be any water flow, and so you don't get any electricity at that time. Another method of getting renewable energy source is geothermal, which means you're using the heat that is in the earth. So it's underground heat that you're looking for, such as volcanic areas and hot rocks. The steam that is generated from those hot rocks can turn the generators and produce the electricity. But of course, you are location dependent, because you've got to go where the volcanoes are, or where the hot rocks bring the hot Earth's contents to the surface. And for example, there aren't any places that I'm aware of in the United Kingdom where that is the case. Biofuels are a possible source of energy. They basically rely on plants that we grow, and of course can be regrown, or plant waste. Essentially they are burnt to produce heat, and then you have the same process of that heat turning a turbine that turns a generator that produces electricity. You can use straw, wood chip, ethanol, which is of course alcohol, or methane, which all in varying ways are produced naturally. We'll cover the effects of coal and oil when we look at the human impact on the environment later on, and we have already covered the implications of using nuclear fuel when we looked at nuclear fission and nuclear fusion. So we'll finish this video just by considering the overall issues that need to be considered when you select a power source for your energy supply. First, there's the question of the setup costs. How much will it cost to put something in place to provide the electricity generation? What will be the running costs? How much do you have to continue to pay to get that electricity generated? What are the decommissioning costs? When you've finished, how much does it take to take this apart? You'll remember that nuclear power stations have very high decommissioning costs because of all the radioactivity that you've got to be aware of. What is the reliability of the source? If you're dependent on wind, or you're dependent on waves, or dependent on the sun, then you're not going to get any electricity if there's no wind blowing, or if there's a calm sea, or if there are clouds overhead. What is the impact on the environment in terms of pollution? Carbon dioxide, sulfur dioxide that produces acid rain. What about the visual impact on the environment? Sometimes things don't produce CO2, but they just look awful. Many people complain about windmills, not only because of the look spoiling the view, but often because of the noise that they make and because of the flicker that they can cause. If the sun happens to be behind them and the windmill is rotating, you get this kind of low frequency flicker of light that can be very irritating. So there's the noise. There's also the impact on wildlife. If you flood a dam, any wildlife that used to occupy that valley can no longer do so. On the other hand, you might argue that different wildlife that like to live in lakes, will inhabit it. Then you've got to think about the location of your power station, which will often be determined by the source. You need to put windmills where the wind most likely blows. You need to put wave machines by the sea.